Hello, hi, good evening. This is our Dasaradha Sir back with you, new concept of the theory of computation. We have seen yesterday some of the useful concepts and very useful tips how to solve the questions and what are the best approaches to solve a problem. Today we are going to have here very interesting concepts and what are the areas you have to be focused in the context-free grammar and push-down automata, Turing machines in undecidability areas. Before that, I just going to throw you a few more questions on the finite automata and regular languages. After that, we see the important topics in the context-free languages and push-down automata. Look at this, the questions are very popular questions, and these models are going to be more frequently asking in the examination. So that's why pay the attention during my explanations of the questions and answers, and also be practice as many questions as possible in these models. Let's back to the new question here. Look at the problem statement in the regular expression concepts here. Consider the language L equivalent to 111 and 2 ones, whole star. The minimum number of states in any DFA accepting this language is option A 9, option B 5, option C 8, so option D I'm not dropping to you here. This model was asked in the year 2007, and frequently I can find here the similar model question in examination. They ask the here find the minimum number of states required to accept the language generated by the regular expressions. So I have given you one of the simple regular expression. You have to find it out what is the number of states you require to answer these questions. And when I am dropping the questions are here, you don't always look into the finalization of the answers by looking at the options. My suggestion to all of you, while you are preparing for the examination, it is very important to do the proper analysis on the options and proper analysis on the given problem statements. That is the way of learning of the concepts. Do the mistakes as many as possible, but learn from every mistake something here. Here I am not dropping here the option D. Option D, I let you know, you may find the answer within these 5 options here. We have here just 3 options. You just find it out what could be the right answer among these 3 options here. Is it 9, is it 5, is it 8, or still it's better than that. When you look at this expression, you will find it out here. Input alphabet for this problem is very simple. You don't have here multiple things here. We have only one input alphabet symbol here. This is using sigma equivalent of only 1 here. The general strategy to do this kind of problems, we have to convert an expression into the finite automata. Finite automata generally will be in the form of a non-deterministic models. Later it has to be translated into the deterministic model. Further you have to convert into the minimum state to DFA to get the right answer of this question here. However, we are not proceeding that approach to answer this question. I am going to handle this one here in the different approach. As you seen, the input alphabet for this only one symbol. Let's identify what kind of strings I can generate from this expression here. What is the first string you can have it from here? You can have it from here, epsilon is the first string because of whole star. After that you can have here the second one is 2 ones. Further, you can have a 3 ones. Now you just go for string generations from this expression. You just identify this is just like a and it's a B. So this is a plus B whole star here. In a plus B whole star, you can find your epsilon, A, B, A, B, B, A, all of them will come here. And just thinking in the similar manner, if you take this is a B, if you write the 2 times, you will get a 4 ones here. If you write here this one and this one, you will get a 5 ones here. If you write it is like a BA. If I write AA, I'll get here 6 ones. I'll get the 6 ones here. And so on, you will write it. Will you get the 7 ones here? Yes, you can have it. How can you have the 7 ones? You take B 2 times and 1 time from the A, 7 ones will come. Can you get the 8 ones? Obviously you can have it. 9 ones, 10 ones. You will generate any one number of ones here from 2 ones onwards. You can see you cannot produce from here single one, but you can produce here 2 ones, 3 ones, 4 ones, 5 ones, and any number of ones you can generate from here. If you look at this diagram, what you will identify, I need a finite automata to accept epsilon first of all. So you can draw the epsilon here. Make this is a initial and final. Later, take this. That is the first thing it has to be accepted. Single one shouldn't accept here. It shouldn't accept the single one. Then switch to the 1 and go to the new state and apply the one more one. It should accept it. After the 2 ones, you may have here any number of ones here. So you may have the 3 ones, 4 ones, 5 ones. Then you can simply say that it should be accepted. So you just take, this is the state A, state B, state C here. Right? So if you look at this, is the diagram is going to be accept every string whatever you produce from this expression. This is simple technique. You will get it directly the answer to the expression if you do the proper analysis of the language. Otherwise, the traditional process is here. You need to translate your expression into the NFA. NFA you must further translate into the DFA. Later you have to convert into the minimum state to DFA here. You can avoid all of them if you do the proper analysis on the regular expressions. So the exact machine will have here only these 3 states. None of the options what we have is correct here. This is exactly equivalent of the 3 states here. You will never be having here all those. This is exactly equivalent to 3 states. It is the right answer. Look at this. If you apply the concept, what we follow the procedure to generate the answers, I do also perform the task, just observe it. If I take this, this is a NFA machine. This is for the A. I take a 1, later you take a 1, later you take here one more 1, then you take 1 here, and then further you go to the 1 here. Of course, you maybe do it in different approach, but this is the NFA machine because of A plus B whole star. Because of A plus B whole star here. Later, you can name these nodes A, B, C and D. Once you have A, B, C, D, you can translate this one into the DFA machine. When you do the translation, you would see here, this is the state A, and if you apply the 1 here, you will go to the B and D here. Write it. When you are at B and D, B1 will go to the C and D1 will go to the A. This will give you AC here. Now we are at the A and C. A1 will go to the BD. See here, this will go to the BD and C will go to the A here. So this is the ABD. Further, you can also check out here, this A1 will go to the BD and B will go to here C, then D will go to the A here, this is a ABCD. Further, its 1 will be the self loop. And you look at this, this is a final state, this is a final state, this is a final state. But this is not final, but this is a final state because your A is a final state here. Now you have translated your NFA to the DFA. Further, you need to do the minimization on this diagram. For minimization of the diagram, you will maybe applied here many algorithms. You can apply the partition algorithm, You can apply the state elimination method, or else you can also apply the tabular method. Different approaches you can be followed here. But you just use the basic knowledge. You just use the basic knowledge what is possible to be minimized here. Just observe the diagram. You know this is the first state, final state. Later I have the non-final state here. After this non-final state, you have a final state. Once I cross this final state, later on I have only final states. Once you cross this, later on I find here only final states. You can understand, if you terminate either at AC or you terminate at ABD, your answer is for all of them is accepted. Once you cross this, everything will be get accepted here. Then why should you travel this much distance? You can cut it off. Then do the self loop for the 1 here. Do the self loop for the 1. That's how you got this diagram here. That's how you got this diagram here. So when you analyze this expression, and you can directly get these diagrams. If you not done this job, this is the traditional approach you have to be followed. Right? So this model is very, very important for the exam perspective. You have to determine minimum state DFA, many important questions. You have to be determine for many familiar languages what could be the right number of minimum state diagrams or minimum number of states for the familiar languages. For many of them you should have here all the answers on tips. Standard questions should have here standard answers. For them you no need to think, rethink many times. You can just simply identify what could be the right answers for them. You identify some of the questions like set of all strings over 0, 1, such that third symbol from the right hand is 1, such that third symbol from the left hand is 1. Length of the string is divisible by n, and you take your number of a's divisible by n, number of b's divisible by m. For all such a standard questions, your answers must be always on the tips. Why? Because the standard questions, they usually ask in the different formats. They may not ask such a direct questions, but they may represent the same questions in the different ways. That's all possible to be catch that concept if you do the practicing of the questions as many as possible. Please do practice the questions as many as possible. You will be successful here. Come on, next get back to the next question here. I just take you to the similar model question on the regular expressions. Just coming back to this here. I'm just taking care about this. So this is the one of the question will always make us to select the wrong answers. There are a lot of misconceptions for the people while you are selecting for the regular expression for a given regular language. This is the question on determining the correct regular expression for a given regular language. Take down the regular language statement here. Which one of the following regular expressions over 0, 1 denotes the set of all strings not containing 1, 0, 0 as a substring? As you are aware, for every regular language, the regular expression is not necessary be a unique. It's not necessary be a unique here. You can have multiple number of expressions. So that's why I have mentioned here there are multiple options has been given. You have to figure it out what would be the right expression to represent this statement. Let's look at the options here. Option number A, 0 star 1 plus 0 whole star. B, 0 star 1 0 1 0 star. Later it's a 0 star 1 star 0 1 star. D is 0 star into 1 0 plus 1 whole star. So you have here these 4 options. You just take your own time and tell me what could be the right answer of this. Just check it up. Take a minute time, work it on this problem, come up with your solutions. come up with your solution here. Look at this. Try to understand the problem statement. Try to understand the problem statement and identify the right section or right answer from these 4 choices. Look at this. Take your own time here. I just mentioned this question is like a MSA, multiple selection answers. It doesn't mean that always you should have your multiple answers. You may have, may not have it. But there is a choice to have your multiple number of answers here. If you find something is a multiple here, then you have to figure it out. What are them? What are they are multiples here? Yes. Now let's work on this problem and determine what is the most appropriate or what is the exact answer corresponding to this problem statement here. Yes. I suggest you, please look at the statement of the problem and write the strings of a language starting from very first string. This is the approach you have to be followed. It will never miss your right answer. The approach, whatever I suggest you followed, definitely you will be find out here what is the exact answer. Many of the people will do here guessing of the answers. Yeah, definitely you can do the guess, but the guess approach also should be more concrete manner. It should be the more concrete approach. Then how to determine that? That's what I'm saying here. You please look at the problem statement and write the expression statements or list out all possible strings of the statement right from very smallest string. Write down all possible strings as for the problem statement or language statement right from very smallest string. Look at this. Denote set of all strings not containing 1, 0, 0 as a substring. If you think really, this problem is a complementary language for contains substring 1, 0, 0, 0. If I would ask you determine the regular expression to produce all the strings containing the substring 1, 0, 0, you would write here this is a 0 plus 1 whole star 1, 0, 0 into 1 plus 0 whole star. You can have this approach. This statement and this language is a complement to each other here. He is saying that it's containing the 1, 0, 0, but what is required for us do not contains 1, 0, 0 as a substring. And if you see this is a L for you and its complementation L dash is a sigma star minus L. What is the L will produce? L will produce here 1, 0, 0 is the first string I can have it. Second string I can have it here 0, 1, 0, 0 you can have it. Or else you will find here this is going to be like a 1, 0, 0, 1 and so on you will write these strings here. What I have written here, this is the language containing the substring 1, 0, 0. Now we have to find it out what is the language members in the L dash. L dash is nothing but sigma star minus L. In a sigma star you have here every string because it is a universal set. What is the first member? It will give you epsilon. So my L dash first member is what here? Whatever is not there in the L, all the members whatever you have in the sigma star must be included here. So in a sigma star I can figure it out here, very first string is epsilon. Later you can find 0, you can find 1 here. You can find here all length 2 strings. All length 2 strings you can find. And all length 3 strings also I can find in the L dash except 1, 0, 0. Except 1, 0, 0, rest of the things will be present in the year. So you will say 0, 0 possible, 0, 0, 1 possible, 0, 1, 0 possible. And you will say that 0, 1, 1 possible, but you don't have this. But 1, 0, 1 is possible, 1, 1, 0 possible, 1, 1, 1 possible. I am just writing off the members what is there in the L dash here. What is asking? Is asking for this. What expression can produce these members? You have to find out here which expression can produce this. That is the problem statement. We have to determine all the strings which do not produce 100 as a substring here. They all are the strings do not having the 100. That's the reason you have to go back to the each option, figure out what are the possible answers for them here. Look at this. Very first string I can have it from here, epsilon will come. That's fine. And also will give you 0, that's fine. Apart from that, everything I can have it what is there in L dash, but I also can have here 100 from this family. 100 also possible to get it from here. So that is why this is not correct. And you come back to this, why you can eliminate the B? To eliminate the B, the biggest reason is here. First string it will give you 101 because of this. I can guess from here epsilon. I can guess from here epsilon. Very first string I can have a 101. But in this statement, first string is here epsilon. It can't produce epsilon. It can't produce the 0. It can't produce the 1 here. If you see all of them, you will never find here this set through this B. Strike it out. Then come to the C. Come to the C. C may be selected by the choice of the people because you will never get 100 here. Absolutely you will not get, because double one, it's a whole star, you maybe have the 1 1 1 1 1 followed by 1 0 followed by 1 will come here. This will give you any number of zeros followed by any number of ones here. After that 1 0 you can have it. After that you can have here any number of ones here. You maybe select C, reason for that it will never produce this. That is fine. It may not be produced 100, but you have to ensure that is it producing rest. The set of all strings is asking for that. Can you produce all of them here? It has to be produced epsilon first. That you can't produce. Very first string I can have here just 0. Later, can you have the 1 here? You cannot have 1 alone. You cannot have 1 alone. So that's why this is fail. Later you can have the 2 zeros. Yeah, 2 zeros I may get it. Can I have the 0 1? Yes. Can I have the 1 0? Yes. You can have it. But 1 1 I cannot have it. So that's the reason. You don't need to verify all of them also. Very first step itself, this is the first thing I supposed to have here epsilon. That I can't have it from this C. Later I need to have a 1 from this. 1 alone you cannot produce from here. That's why this is fail. Then come back to this. Is it producing all of them here? That's the point. You know, this is going to be give you 0. Epsilon will come. 1 0 will come. Yes, 1 1 I can have it. Can you have the 00? Obviously. You can have the 0 1. Yes, you can select the 0. You can select the 1 here. Or can you have here 1 0 here? Yes. Can you have the 1 1 here? Yes. Can you have the 000? Yes, you can have it. But 100 will not come, but all of them you can produce here. That's the reason you can see L dash, or you can say the problem statement is represented by only D. It's only D. So friends, my suggestion is here, while you are preparing for this course, this is very, very important to understand analysis of each and every option. Analyze every option. And you should have a strong reason why you do want to refuse the options. Why do you want to reject the options here? You select one a strong reason. Strong reason in the sense you have to have some evidence what is the reason you have been avoiding here. What is the reason for avoiding of it? You know this is the string is possible from here, it is not possible here. Such a evidences you have to be figured out. and then you can be confidently say that what is the correct answer of it. Fine. So this is the models you can expect on these titles. So finally you can take now to the next question, be ready for that. This is most frequently asking model numerical answer type. As I said, determine minimum state to DFA to accept all the strings ending with 10, For these standard questions, you will always have your fixed answers. Whenever this is a statement like end with some string like a 10, or else contains the substring like a 10, these problems will have your direct answers. You can start construction of a diagram with reference to the very first string here. You take the 1 transition and 0 1 transition. This is the first string I can have it. According to this problem statement, if you write a first member of a language, it's a 10. Use this first statement member, then write a member of the diagrams. You write the states of the diagram. Whatever number you will get here, this is the answer. You don't need to worry about whether I should have here completion of this remaining edges, what is missing here. Here, standard questions I said, ending with 00, containing the substring. For all such a questions, your answer is very simple. If string length is 2, machine required here always 1 state extra. If there is a substring whose length is suppose n, the corresponding minimum state automata always required n plus 1 number of states here. If there is a string whose length is suppose n and it's a substring problem, definitely you can say that this is required here just n plus 1 states. So the problem may be ends with 10 or contains substring. Their answer is always depends upon what is the string length you have been using at the end, or substring what you are using, what is the length of it. These two will be fixing the answers. So here, as I said, whenever it's a substring problem or containing substring problem or ending substring with something called, then you can simply say this is required here just n plus 1 number of states. Sometimes I have seen one of the question, it's a sigma star 101 whole star. It required how many number of states? How many number of states you required in the minimum state to DFA to accept the language sigma star 1011 sigma star. If you look at this, you can easily understand what is the problem statement for this, or what is the language I can give it for this expression. The expression statement I can provide here, this is containing the substring 1011. Containing the substring 1011 here, right? What is the length of it? 4. Then what is the number of states are required for it? You require just 5. They won't ask the problem always like a containing the substring or do not containing. There somewhere you can find here the similar statement or the same statement, they may be put into the different ways to represent. Then you should be good at here doing of this conversions, or you have to interpret your questions here properly. Is it the different question or it's going to be the similar to the existing thing? Most of the times you can find here it is existed one only but represented in the different forms. Represented in the different forms. Now it is your intellectual capabilities how you are going to be interpret or you are going to be correlate the base problem and modified version of the problem. That's very important here. So this is the one thing you have to find it out. My suggestion to all of you, practice as many questions as possible in this area. Finding of a minimum state to DFA is one of the guaranteed topic for the coming up examination in 2023. Later, also you look at your DFA concept, determine the languages, what they are corresponding to. That is also one more concept you have to be focused. Similar way, let's move on to the other questions, what you can figure it out here. Just look at the problem statements. If you see this, consider a DFA over sigma equivalent to a comma b, accepting all strings which have number of a's divisible by 6 and number of b's divisible by 4. What is the minimum number of states that a DFA will have here? This model is also one of the prime model. I have seen these models in 2000. In 2007, they are given the one more question. In 2015 also I have seen one question on this model. For these questions, it is impossible to be design the machine in the examination. What you can do, you can reduce the complexity of the problem. You have your very, very complex problem statement here, because one number of a's are here 6, other one is about the 4. Instead of that, you take a number of a's are divisible by 2. Number of b's are divisible by 2. This is the base problem. The same problem you can be also written as, or you can be treated as, number of a's are divisible by 2, number of b's are divisible by 2 means even number of a's and even number of b's problem. Even number of a's and even number of b's problem is required here just 4 states, right? Why you got the 4 states? Because number of a's you are dividing by here 2, number of b's also you are dividing by 2. Altogether possible combination of the remainders would be here the 2 into 2, 4 combinations will come here. If you enhance this concept to any other complex problem, you can easily figure it out what is the answer for it. The right answer for this question is here, a's are divisible by 6, b's are divisible by 4, right? So b's are divisible by 4. Ultimately, you can find here, this is required here 6 into 4. This is equivalent of 24. Likewise, some of the standard questions should have here standard answers. All these standard answers must be always in the tips. Let's have a small break and then come back to you with new concepts. Be ready for that. Come with your new concepts like a push-down automata and CFGs, and then we'll see many more useful concepts after the small break.
Of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself, Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now I divide my preparation strategy into 3 basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESE 2021 from E&T branch. I took ACE Postal Course, Mains Test Series and Interview Guidance Program in ESE 2020 and ESE 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESE 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my.
Welcome back. Now let's look at the topics of context-free grammar and push-down automata. What are the areas you need to be focused for exam? And what is the scope of the problems in examination? Most of the times you can have a scope to get here 2 marks question on these 2 areas. Sometimes the questions will be on the topic of context-free languages, or very rarely you will find here the questions on the push-down automata. In the context-free languages, you will see here most of the times the questions on the language identification in CFGs, or you will say that CFLs. Language identification is one of the key area. Focus on this. And you also must differentiate what kind of languages will fall into the category of DCFLs and what the languages fall into the category of CFLs. Also you have to find it here, what are the non-CFLs? That's very, very important. So you have to good at this topic. Whenever it's a DCFL, you can have your perfect idea of designing of PDA to recognize the language. Say, I have the language L is equal to here, A power n, B power n, such that n is greater than 0. This is the perfect DCFL. Why? You can easily design your push-down automata for it. What is the general approach? To design a PDA, you have to push all A's onto the stack until you determine the B. Once you figure out the B, later you have to start pop operation. When you know the clear-cut idea about what to push and where to start the pop, all such in languages, you can consider they are the DCFLs. This is the simple tip you should recognize always, right? Whether the languages are here CFLs or DCFLs. And you know, very, very popular example of a DCFL, it is a odd length palindrome. This may be defined on any alphabet like a either 0 or 1 or AB here. You just have it. Perfect an idea what is the procedure to design a machine. To design a machine, you can see all W values must be pushed onto the stack until I find the C. You have to push all these symbols, whatever you have, in the W until you find the C. When you find the C, you have to do the skip. All the C symbols must be skipped here. After the C, what to do? You have to do the pop. You have to push symbols of a W onto the stack, skip the C values, Later you start popping operation. Whenever you have here such a perfect idea to design a logic, then this is DCFL. This is DCFL. So you have to good at recognizing of the languages whether they are the CFLs or DCFLs. Whenever you take a CFL, CFLs will have here multiples, options. You will never get here exactly one combination of a design procedure. You have to choose here always the paths like a either or. Say for example, you have here one of the languages we use, L is equal to W power R, W belongs to here A comma B whole star. Suppose if you have this language, there you can say that this is the CFL but not DCFL. Main points what to be recognized in the CFLs, focus on closure properties. And you should be good at here learning of both the properties. What are the closure properties of the CFLs, closure property of the DCFLs? Both are very, very important. As far as the closure properties are concerned, related to the CFL here, they are not closed under the two operations. One is complementation, other one is they are not closed under intersection. All the times the question will go around these two topics. You go and refer any of the previous papers you can find here. If L is a context-free language, complementation of a L not necessarily be a CFL here. People will say that if L is a CFL, L dash is not CFL. That is a wrong statement. This is the misconception. If L is a CFL, L dash is not a CFL. That is the not correct statement according to the closure properties. What closure property says here, if L is a CFL, L dash may be CFL, may not be CFL. Or else it's not necessary be a CFL. So this is the verbal English. You people should be good at here, see the statement. Understanding of the statement is very, very important. Not CFL is a different meaning. Not necessary be a CFL here. So these two are very, very important properties. You have to be working on this. And intersections. If L1 and L2 both are CFLs, its intersection is not necessary be a CFL. For that we use always one important language combination which is A power n, B power n, C power m, such that n and m is greater than 0. And I have here L2, this is going to be like a power m, B power m, C power m. Suppose I have taken this language, both of them are here context-free languages. Both of them are context-free languages. If you take what is the intersection of it, L2 intersection L1, this will give you here A power n, B power n, C power n, such that n is greater than 0 will come here. This is not a context-free, it's a context-sensitive. Very, very popular context-sensitive language it is. Right? So as far as these two concepts are concerned, I told you work on language identification, work on closure properties. Closure properties. That's it. Once you do this, then you are almost done this chapter. Apart from that, what else you can have here? Apart from that, they may be ask you from a grammar identification of a languages, as I said. Grammar will be given to you. You have to recognize what is the language of a grammar. Language of the grammar. You have to good at your identification of it. Right? So I just go to the next one here. Whenever you wanted to find a language from a grammar, it's very important finding of exact language what is asking. You may have the options as it seems to be like a all are right. because of they have very close associations. One language may be the subset of another language. One language may be a superset of another language. When you look at all in that angle, you feel here, yeah, option A, option B, option C, all are seems to be correct here. I'll give you such an example. You can figure it out here. What is the approach to be solve this kind of questions here? Look at this here. I have a grammar, very, very popular grammar. S tends to A, S, A, B, S, B, R, A, R, B. I have this one here, suppose. Then find out. They ask you, find language generated by the grammar. Generated by the grammar. What is it? It's a set of all strings. Set of all strings over AB. You have this option, suppose. Over AB, option A, all palindromes. You have option B, even length palindrome. Even length palindromes. I have option C here. This is a odd length palindrome. You have option D. You have, suppose, the statement like string that begin and end with same symbols. Look at these options. When you wanted to find out the correct answers, you have to do this. Look at the grammar, identify the strings, what it can produce, derive the strings starting from very smallest string. From this one, you can see very smallest string I can produce. This is like a and B. Further, you can have here triple A. You can have a triple B, or else I can have a ABA, or else you can have a BAB, and so on. You will write it here. All are palindromes. All are palindromes here, whatever you are producing. But palindromes not necessarily be what the strings you have in the set. I can also say on this alphabet, AA can be the one of the palindrome. BB can be one of the palindrome here. Got the point? But you cannot produce that. You cannot produce that. That's the reason you will say that A is failed. Whatever you are generating here, this is all called even length palindromes. That's why this is also failed. Because I cannot produce only AA, I cannot produce only BB here. Further, take down C and D. Odd length palindromes. Whatever you are generating, all of them are here odd length, right from the A. A itself is a palindrome, B itself is a palindrome. And people may also go for here D. The reason for that, strings that begin and end with the same symbols. That may be common to the idea because of this grammar structure, begin and end with the same symbols. But the fact is it necessary to be always palindrome as for the problem statement D, or as for the given option D? Is it necessary to have all the strings which begin and end with the same symbols as a palindromes? That's the point here. You have to think in that way. According to this statement, I may say that A, B, A, that begin and end with the same symbols. But it is not necessary to be a palindrome. As for the statement of the D, you can say this is also one of the member. It's a one of the member. But you can't produce it from here. You can't produce it from here. Suppose I take here A, B, A. I have this. You got the point? You know the first member and last member. It is the same symbols. But this is not a palindrome. So that's why you have to think this way. D is not the right answer. Only C is the correct answer. If you do analysis of all these options, what you understand, you know D is the superset of everybody. This is contains palindromes, non-palindromes. Because of this statement, everything will begin with the same string, same symbol and end with the same symbol, right? So D is the superset, and in this superset, you will have here both kind of strings, palindromes, non-palindromes. So I would say within this definitely I can find here there is a palindromes. What that? That's option A will be there here. Then what else? This A is representing there are even palindromes, odd palindromes, both of them. Even palindromes or odd palindromes. Yeah, there are two parts in this Sagnagi. What you'll find here? There are two parts here. What they are? What they are? They are here, it may be either option B, one side, other side can be here C, another side. So what you will find here, this is the analysis. Why you all feel here D correct? D is absolutely correct here because of this confusion, because this is a superset of everybody. But exact answer what is there for this grammar is equivalent of only odd length. This will give you only odd length here, right? So this will give you odd length, that's it, right? So every time whenever you are solving a problem, every option need to be studied very carefully. Do the proper analysis, you will be very, very, very successful here. Later, and once you've done this, next step of you, go to the topic of Turing machines and undecidability. As far as the Turing machine and undecidability concepts are concerned, you will get most of the times the question on theoretical concepts. You have very less scope to have a question on problems, or you don't have here any question on numerical answers. Most of the times the questions will be on theoretical statements or theorem statements. So my suggestion to all of you here, whenever you have here such a problems related to the decidability or undecidability, altogether there are about the 20 to 25 direct statements you can find out in the Willman book. You please refer the statements of a Introduction to the Automata, Languages and Computations by the Aho and Willman and Rajiv Motwani. In the textbook, you please take down all the theorem statements related to the decidability and undecidability. Those statements will be repeated as it is. Along with those statements, you can find out here one or new statements will be added to those. That statements you can easily identify whether they are the decidable or undecidable. To say something is a decidable, I share you two important tips to decide it. To say something is a decidable, identify is it a true statement or false statement. Check in this direction. If you find some statement is always true, that is absolutely decidable statement. I take for example, intersection of a regular languages is a regular. It's a true statement. Then you should say that statement is absolutely true. Then you can say this is a decidable statement. Complementation of a CFL is a CFL, it is a false statement. then it's an undecidable statement. So if any of the statement, if you feel it's a true statement, if any of the statement you feel that it's a possible to do that, you will consider that is a decidable statement. Whenever you find there is a false statements where you don't have an algorithms, where you feel that it's not possible at all such a statements you can generally fix it as a undecidable problems. So this is the simple trick you can use here to figure it out whether those languages are here decidable or undecidable. As far as the Turing machines are concerned, no question directly come on the Turing machines to solve numerically. What you can expect here, there are the questions on the recursive languages and recursively enumerable languages. This is very, very important. Identifying whether a language is rec or recursively enumerable language. You please do understand, recursion is the synonym of the decidability. Very, very important term I am just sharing with you now. Recursion is synonym of the decidability. If you find any particular problem is a decidable problem or it's a recursive problem, both are same meaning here, you will always fix they are the decidable problems or else you will say that they are recursive languages. Apart from that, properties of these are very, very important, especially the complementation problem or complementation property. Recursive languages are always closed under the complementation, whereas recursively enumerable languages are not closed under complementations. So the problem is always goes around this statement and solve the problems based on this statement, whether the given L values are rec or recursively enumerable, and you have to look into the operations of the different combinations of the recursive operations and recursively enumerable operations. So as far as the operations are concerned, only two operations are very important for these two topics. They are closed under complementation, but these are not closed under the complementation. That's it. And you will be finding the direct question on these properties. Whenever they're asking the question on the properties, it's not necessary be always exclusively on the topic of recursive. It is the composition of all the topics, right from the regular language properties. They mix with your context sensitive language properties, and they mix with your recursive language properties, recursive enumerable language properties, context free language properties. All the properties are going to be here mixing together and then form a one particular question. If you see on all previous questions, you can find the same trend. Finally, what I wanted to conclude here, you focus on the statements from the Willman, decidable statements or undecidable statements. There is a definite question on the decidability or undecidability for coming up examinations. Apart from that, you have to be good at here the properties of various formal languages. Once you good understanding of the formal language properties, definitely one more question you can be easily answered here, right? So as far as the TOC is concerned, the basic concepts and important topics what to be covered has been covered completely. You just follow the tips whatever I shared with you. You will definitely going to be very, very successful. Only big mantra to be successful in this examination, practice as many questions as possible. That's the only way to be successful in this course. If you wanted to be excel in this course, you have to solve here all numerical questions. And this is quite easy if you depends on this particular problem statements like a Turing machines or undecidability, their direct theoretical statements will be coming into the examination, right? I hope you all enjoyed my session. Definitely these tips again and again you just watch it and figure it out all possible notes and take the important all the important points as a separate note and followed and apply the same concept to solve the problems. I wish you all the best for coming up the GATE exam 2023. This is your Dasaradha Sir signing off for the live set today.
program in ESE 2020 and ESE 2021.
Hello everyone, my name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESE 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself, Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now, I divide my preparation strategy into three basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESE 2021 from E&T branch. I took ACE postal course, mains test series and interview guidance program in ESE 2020 and ESE 2021.
Hello everyone, my name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance